You gotta click all the right buttons, everybody. Okay. So this was, again, a homework review. Page 99, numbers 1 to 16 all. Some of them were multiple choice, some were free response. If you want to check if you got them right, I can go over those. If you're not sure about things, looks like numbers 5 and 8. Are there any other questions that you want me to go over? 13. Okay. If you take a look at your textbook, check it out. If you want to know if you're right, if you have a question about something that you're not sure about, some of them were easy, some were a little bit more tricky, but it's a good practice for our test. These kinds of questions are the kinds of things you need. Oh goodness. These kinds of questions are the kinds of things you need to know how to do for the AP test. These questions are taken directly from previous AP tests. Alright, I'll see how much time we have for these. Again, these are taken from previous AP tests. So, directly the kind of things you need to know. Alright, let's go over some of these. Let's see what I can do. Starting with number 5. Number 5 says, on which interval is the graph continuous? Is f of x, we have this equation here, it's 2 over square root x minus 1, not continuous. Not continuous. And we have some choices. A is 2 to infinity. B is parenthesis 1 to infinity. C is bracket 1 to infinity. And D is 1 to 2. Parentheses. On which interval is that not continuous? So we need to know what the graph of this looks like, right? We need to know what the graph of this looks like. Or what situation is going to cause problems for this equation, right? If it's asking about continuity, we got to figure out what number in this equation would give us something that is a problem. And Lizette's correct. Garcia said, we cannot use technology, and that's true. On the AP test, there will be sections where you will not be able to use a graphing calculator, and you'll just have to use what you know about the rules of functions to identify when things are a problem. So if it's asking for something about not continuous, or if something is not breaks continuity, what we're really looking for is when is this function, at what number, at what x value, is this function going to have a problem? Is something strange going to happen? It's 1. Yes, correct. Lisette says it's 1. Exactly. We know that x is going to have a problem when it's equal to 1. When x equals 1, we're going to have 2 divided by 0. And that's going to be a problem. So at 1, it's going to be a problem. So it's not A, right? We don't need to worry about A. But is it B, C, or D? Is the question. B, C, or D? And the difference, right, with B and D, both of these have a parenthesis, and C has a bracket. Does someone want to describe, or does someone remember, what the difference is between the brackets and the parentheses in intervals like this? What does the difference mean? Anybody want to describe that? Bracket or parenthesis. All right, I'm going to call on somebody. Let's say Michael. Mr. Jones, can you describe the difference between a parenthesis and a bracket? What do they mean? I think he's typing his answer. Brackets or parentheses. It's important to know this difference. Typing your answer, Michael? I want to make sure. All right. Audio. Having a problem today. All right. So Michael, you're taking a while. Okay, you want to make sure you're right. Well, let me explain, and then we'll see what your explanation is. All right. So to answer this, what we've got, a parenthesis means it is not included. Exactly. Thank you, Mike. To show if a point is included or excluded, right? So the parenthesis is not included, and the bracket means it is included. And so since we know that 1 is not allowed, going up to the parenthesis is okay. We're saying we're getting up to 1 but not including 1. Because 1 is where the problem is. So we don't include 1, those are fine. Those are fine. This one also fine. But if we include 1, that's where we have a problem. We're not allowed to use 1. We're not allowed to use 1. So C is the right answer there. C is where it is not continuous because we're not allowed to include 1, and C is including 1. The bracket says we're including 1, and we're not allowed to. So C is not continuous. That's the one that's not allowed. Again, they give little tricks like this. Make sure we know what parentheses are and brackets are. All right, number 7. 7 says, okay, so we got a graph. We got a graph that looks like 1, 2, 3, and then 1, 2, 3, 4, 5, 6. It goes kind of like down here to 2, and then 2 has a point up at 3, and then it goes across to 4, it goes down to 6. The question is, which of these are true? Which is true? And it gives us 3 options. The limit, number 1, the limit as x approaches 2 of g of x equals 1. Option 2 says the limit as x approaches 2 of g of x equals g of 2. And option 3 says g of x is continuous at x equals 2. Oh, at x equals 3. Okay. So this is a graph of g of x. We have these questions. Which ones are correct? So check them one by one. Does the limit as x approaches 2 of this function equal 1? Let's check this, everybody. Yes or no? For number 1. Does the limit as x approaches 2, right here's 2. Does the limit as x approaches 2 equal to 1? Let's check. From the left, our limit looks like it's going towards 1. Yeah. From the right, going towards 1. Our limit as x approaches 2 seems to be equal to 1, right? We're matching here. I mean, my graph is a little off. Should be here. Close enough, right? Close enough. That one, though, seems fine. Number 2 is asking, does the limit as x approaches 2 equal the value at 2? Equal the value at 2. Is that one a yes or no? Well, we know the limit part is 1. What's the value of g of 2? The value of g of 2 is going to be up here. And it's going to be 3. Right? The dot tells me the value. This is g of 2. And down here, this is the limit as x approaches 2 of g of x. Right? That's the limit, and that's the value up there. So clearly, right, the dot tells us where the value is, the limit is where they approach. So these are not equal, that one's not allowed. Third question, is g continuous at x equals 3? Here's 3. Does the graph look continuous there? Is there any kind of discontinuity, any kind of hole, or vertical asymptote, or jump discontinuity? No. Remember, it's a straight line. Looks fine. Look at the graph carefully. Look at it. Right? Looks fine. It is continuous at 3. It's not continuous at 2, right? This is a hole, right? At 2, we have a discontinuity, but at 3, we're okay. 3 is fine. But 2 is a discontinuity. So they try to trick you. Make sure you check exactly which one they're looking for. Continuity at 3 is yes, that's continuous. At 2, though, it is not. At 2 is the break. So the answer was, which is this? B, letter B, 1 and 3. They like these kind of questions on the AP test. Let's look at number 8. Number 8 says, we have another graph. Another graph here. And at 1, we have a vertical asymptote. At 1. And then we have 2, 3, 4, 5. 1, 2, 3. Graph starts here. Kind of goes up like this. At 3, it looks like it goes kind of like this, touching 3, and then starts again down here and goes up, and then this has a dot right there, 2 and 3. So it asks us, in this graph, which of the following is true? Which one of these is true? We have A, that's saying the limit as x approaches 1 of f of x equals infinity. B, the limit as x approaches 3 from the left side is less than the limit as x approaches 3 from the right side. That's a less than sign. Is less than. C says the limit as x approaches 3 of f of x equals 1. And D says the limit as x approaches 0 from the right is equal to the limit as x approaches 3 from the right. So which of these is the one that is true? What do we think, folks? Anyone have a thought? Should we just check one by one? Let's start with the easiest one, letter A. Limit as x approaches 1 is infinity. Is that true? Well, one side, here's 1. Here's 1. One side definitely goes to infinity, but the other side does not. So since they're separated, right, this does not equal infinity. In fact, it equals d and e. The limit does not exist at 1 because they both go to different directions, right? We talked about infinity limits, how they go to different directions. That means the limit doesn't exist. So it's not letter A. Letter B says the limit as x approaches 3, make sure this is a 3, from the left side is less than the limit as x approaches 3 from the right side. So let's check those out. X approaches 3 from the negative side is this one. This is 3 from the left, from the negative side. You're going from the 3, like the lower, the negative side of 3. Negative side of 3. And approaching 3 from the right side, this is the positive, not there, this is the positive side of 3. 3 from the right side. Right, the left side is the negative side, lower than, and the right side is from the positives coming towards the positive, right, down from the positives. So we have these two sides. So is this negative side less than the positive side? Negative side less than the positive. Does not seem to be the case. The negative side is up here at 3. This is going to be 3. And the negative side is down there at 2. So clearly not either. All right. So you're just really carefully looking at the function, carefully looking at the graphs. Look at part C. Is the limit as x approaches 3 equal to 1? What do you think, everybody? Does the limit as x approaches 3 equal to 1? Well, here's the value. But remember, this dot here means this is the value f of 3. Not the limit, this is the value. The limit means both sides have to be the same. Both sides have to be equal. If we have a full, this is a full limit. It's not left or right. Right? We have our full limit. The total limit means that the left side of the limit and the right side of the limit have to be matching to each other. Right? Both sides have to be equal. And in the case of 3, one is up, one is down, we don't have a single spot, and it's definitely not equal to 1, so it's not choice C. Looks like our answer is D, but let's make sure that we don't that we didn't screw up at all. Limit as x approaches 0 from the right side. So here's 0. We're approaching from the right, we're coming this direction. And it looks like that limit gets us here at 2. Directional limit's real important. Limit from the left, from the right side, limit from the right, that's going to be 2. X approaches 3, limit from the right side here also looks like it's going to be meeting us at 2. So it looks like that one's okay. And that seems to be our answer. All right. So is this helpful, folks? Am I talking to the void? Give me something. Let me know. Is this helpful? Helpful little review. 11, 12, 13, 14, 16. Just these little details become important, right? What does the parentheses mean? What does the limit from the left mean? What does it mean to be infinity? All these little details. All right. Let's see. I'm going to do I'm going to do two more points and holes in graphs. Yeah, the graphing, being able to read and interpret the graph there is real important. All the holes and stuff like that. All right, so I have 11, 12, 13, 14, and 16. Let's see. Which ones do I want to do? I'm going to do... Oh, 11's interesting. I'm going to do 11 and 13. Maybe 14. I'm going to try doing just two more. So now we're into the free response section. Technology is permitted for this, which is all right, which is helpful. So we can solve this equation using some calculator, plug in some numbers if we need. Most of the time on the test, you will not need this calculator, but it's helpful to have, just in case you want to double check yourself, things like that. So number 11, it says we have a position function. Oops. Position function. What this means is it is simply a way of describing where a particle is. Like imagine a particle kind of moving back and forth in a line. 4.9 t squared plus 398. This equation, and we'll be talking more about these types of equations soon. This is a motion equation. If you've taken physics, you know the equation of position, x of t, is at squared, it's 1/2 at squared, plus v naught t plus x naught. T is the time. V is our starting velocity. Like, let's say you throw something, right? You throw something up into the air. Your starting velocity is how fast you threw it at the very beginning. Start velocity. A here is the acceleration. Acceleration. This is due to gravity. Most of the time, gravity is slowing the object down. When you throw it in the air, it starts off at a certain speed and it slows down over time until it gets to the top, right? Because it's fast, 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 and it slows down, stops, and then turns around and then starts to fall backwards, increasing speed as it goes down. And this equation describes that motion. X is the position, where it is, how high and how low. A is the acceleration due to gravity pulling it down. And the starting velocity is how fast you threw the object. So, and x naught here is the starting height. Start height. So just a little quick primer on this stuff. Again, we'll go more over this later. But this is asking, we have an equation here. Starting height, it starts at 398 meters tall. It's being pulled down by gravity. And the equation says that this is the height in meters from an object that's fallen 398 meters after t seconds. So we're going to use this equation to do some calculations. Question A says, for between 1 second and 2 seconds, explain why there must be oh goodness gracious, there must be a time where the height is 382 meters. Okay. Explain why. There must be a time somewhere between 1 to 2, 1 second to 2 seconds. That's what this means, between 1 to 2, where the height is 382 meters. What kind of problem is this, everybody? What tool are we going to use? Anybody have an idea? Thank you, Lizette. Yes, the intermediate value theorem. Intermediate value, right? We're looking for a number between something, between a high and a low. Yeah, so we need to do our checks. We're going to use the intermediate value theorem, IVT, and we're going to check to see if there is a time, if there's guaranteed a time, somewhere between 1 second and 2 seconds, right? Somewhere between 1 second and 2 seconds, where the height has to be 382. And I need to state, right, when it says explain why, I need to state how I know. So, first of all, is it continuous? I mean, yes, it's a falling function, it's a physical action, right? This thing is falling down, the rock doesn't jump from one place to another. It is continuous because it is a physical phenomenon, physical situation. Something like that. Number 2, is our y value in range? In range. So we're going to test S of 1 and S of 2 and find out what the boundaries are. Negative 4.9 times 1 squared plus 389. Let's see. 389 minus 4.9 is 38.4. What did I say? 384. 384.1. So my high is 384.1. Plug in number 2, again my low, this is going to be 4. 4 times negative 4.9, so 389 minus 4.9, 4.9 times 4, minus 4.9 times 4 is 369.4, 369.4. So I've got my high and my low. Is what I want between these numbers 382. Well, yeah, 382 is going to be somewhere in here. 382 is between them, so we're good. And so now we write our explanation. Yes, since S of t is continuous. Continuous where? Continuous everywhere? Continuous, we could say everywhere, or you could say on 1 to 2. Specific interval they're talking about, right? Use the specific interval they're talking about, on 1 to 2. Since S is continuous on the interval, and what am I doing? And 382 is between S of 1 and S of 2. You could either write that, or you can say 384.1 and 369.4. You could use the numbers either way. Then, by the intermediate value theorem, there exists a t between 1 to 2 where S of t equals 382. That would be your answer. A statement something like that. All right. Questions about that? So that's part A. The other questions in here I'm not too concerned about, B and C, but I can just show you briefly what they're like. Oops, not D, B. Question B says, when does the rock or object hit the ground? Are people confused about what's happening here for this equation? Oh, 398. What am I doing? 389? Why am I doing 389? People, you gotta tell me these things. 398. 98. Why didn't anyone tell me? 398. I put 389 here. People. Trusted you. 398, not 89, 98 minus 4.9 is, yes, 393.1, and the other one is 378.4. 398. No one saw? No one wanted to help me out? All right. Well, I appreciate you looking up. Thank you for correcting me, everyone. Yes. Either way, though, still we get our number between. Our 382 is still between the two numbers, so we're still okay. 398. Careful, everybody. All right. Part B. When does the object hit the ground? This is a fun question because what do you mean by hit the ground? Hit the ground means the height is 0. We are on the ground. On the ground, everybody. So that means that we're going to set our equation equal to 0. Negative 4.9 t squared plus 398. Set your equation equal to 0 and then solve for t. So let's solve for t. Minus 398 at both sides, minus 398 both sides. Negative 398 equals negative 4.9 t squared. Divide by negative 4.9. Divide by negative 4.9. Cancel those, you get t squared equals whatever that is. 398 divided by 4.9. 81.2. 81.2. And then you square root both sides, square root both sides, square root both sides. T is going to be approximately what? Approximately 9.01. You can just say approximately 9 is fine. Just about 9. 9 what? Uh-oh. I don't have a label here. 9 seconds. If you do not include this, if you leave this off, you lose a point. You lose a point on the AP test. If you do not label your things with units, if you do not label your units, oftentimes they will say in the question, use correct units. If you do not label your units, you do not tell me what it is that we're talking about, you will lose a point on the AP test in the free response sections. If you do not do that. Okay? Please make sure you got those answers. And in part C, we'll have to deal with that later. What else? 13. I like 13. Let's do 13. Last one. Number 13. We have a piecewise function. Piecewise function, we have 1/2 x when x is not equal to 2. And we have 3 when x is equal to 2. So it's a piecewise function. That's this top equation everywhere except for the value of 2. And then it's 3 at the value of 2. So if you had to picture this graph, if you wanted to picture this graph, what would it look like? Something happens at 2, right? 1/2 x looks something like this. But there's a hole right here at 2. It's an empty space right there at 2. And at 2, it goes up to 3 and fills in the dot there. So if you can imagine at 2, if we were pretending this graph was touching 2, it would actually be at 1, right? It'd be at 1. If this is 1/2 x here, 1/2 x is this equation here. We're skipping C, Jessica. I got to do this last one, then move on to our other practice. Number C we'll get to later. But this one, I want to touch this one really briefly. So it's 1/2 x for everywhere except for 2. At 2, it breaks like that. So picture the graph, right? See if you can imagine what this looks like. It really helps to have this visual. At least, you don't have to draw it, but at least knowing what the picture looks like. Oh, we got a function everywhere, right? We have this function everywhere except for this one spot. At this one spot, the function goes somewhere else. We have a regular function everywhere except this one spot. At that one spot, it goes somewhere else. And so that really informs you about how this looks. And immediately, we know a lot of information about it. Immediately, we know a lot of information about this function. And so if we have questions, first question is, does the limit as x approaches 2 of f of x exist? Does the limit as x approaches 2 exist? And it says to justify. Does the limit exist? Justify your answer. When it says justify, we need to use definitions. Whenever it says to justify, it means you're going to use some kind of definition. Could be the definition of continuity, could be the definition of the intermediate value theorem, could be lots of definitions. For this problem, it's asking if a limit exists. So we need to use the definition of a limit. How do we know if a limit exists? What is the proof? What is the definition of a limit? Anybody remember? Definition of a limit. Let me call on someone else. Ayala, do you remember what the definition, how we prove a limit exists? What important pieces we need to show for a limit to exist? Jesus Ayala, are you there? Jesus Ayala, minus 1,000 points. Okay, so the question is, my question was, do you remember what the definition of a limit was? What important things, how you prove a limit exists? How do you prove a limit exists? What are the important, there's two things that are really important to prove a limit exists. Do you remember what they are? To prove a limit exists. You're going to take your 1,000 points. Okay. Anyone else remember? Yes, exactly. Who is that? Is that Haley? Who is that? Thank you, Haley. Yes, exactly. The limit exists when it approaches from the left and the right are the same amount. Adrian, your definition, you're describing a limit when it reaches a point but never reaches it, right? That's a description. But a mathematical definition was the limit as x approaches some value from the left has to equal the limit as x approaches some value from the right. And that means that the limit as x approaches the value exists. But if the two sides are equal, then the limit as a whole is equal. And so that's going to be the definition we use for a limit, right? We say yes, I mean it's clearly yes in this case. The limit as x approaches 2 from the left of f of x is equal to, okay, well, what's it equal to? How do we find limits, everybody? How do we find limits? I want to find the limit at 2 from the left. Limit at 2 from the left. Which function do I use as it approaches 2 from the left? Well, it would be this one. Piecewise functions, you look at where the boundaries are, right? So the boundaries of this first one is everything except 2. So on the right side and the left side, we have this first equation. So we're going to use this equation to find the limit from the left. And to find a limit, we plug in. Equals 1 over 2, plugging in our 2, which is 1. And the limit as x approaches 2 from the right uses the same function. 1/2 times our plug-in value, which is 1. And so we would say the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right of f of x. And this is why, yes, because, that's a little bad, because we'd say yes, the limit exists because these two things are equal. So the reason why, remember, in a piecewise function, you're looking for which equation is in that section. So when we're saying limit as x approaches 2 from the left side, right? From the left side, from the negative side, it's this part of the equation. And that's this equation right here. if we're saying x approaches 2 from the right side, we're saying it's this part of the equation. And this part is the same equation because it's everywhere except 2. If there was like a split, if we said it was one equation on the left, one equation on the right, we would have to test 2 separate equations. But in this case, it's the same one because it's the same equation approaching from both sides. I don't know if that makes sense, because it's just one equation we have here, right? It's this one equation. This one equation is everywhere. This one equation is everywhere. So we use it for both the left and the right side. Okay. Part B is f of x continuous at x equals 2. Is the function continuous at 2? And it says, again, use the definition to explain. So, Alejandro, is this function continuous at 2? What do you think? Is our function continuous at 2? Alejandro says yes. So look at 2 right here, at 2. If I was walking along, am I going to fall in a hole? Or am I going to just walk smoothly across, or if I'm driving a car, I'm going to fall, right? Falling means we have a break. We are not continuous. There's a hole here. So our function is not continuous. Got to make sure, right, we see that there's a hole. If we're going to fall through, right, if we're driving across, we want a smooth connection. We have a hole here, we're going to fall. That is a break, that is a discontinuity. Okay? So we know that it is not continuous. How do we use the definition to justify that? Manuel, do you remember what the definition of continuity was? There were 3 important features of the definition of continuity, 3 things we had to verify. What were those 3 things? Definition of continuity. Do you remember those 3 things, Emmanuel? I will give you 1 second. All right, are we ready? Kidding. 3 things about the definition of continuity. Definition of continuity. Yes. Number 1, f of x exists. There has to be a point that is located in the spot. Number 2, what was the second part of continuity? The limit as it approaches c, yes, the limit as x approaches some value. Really, it's not f of x existing, it's f of c existing. We're looking at a point, right? So the value at that point exists. The limit as it approaches c has to also exist. So the value exists. Value exists. Let me do it here. The value exists. The limit exists. And what's the last thing? The value exists and the limit exists. And the last piece for continuity is, yes, they have to be equal. F of c has to equal the limit. So the value has to equal the limit. Our 3 pieces for continuity. Right? We have to have a point, we have to have a limit, and they have to match. So our answer here was it's not continuous. Which one is broken? Not continuous because why? Do we have f of c? In our problem, f of, we're looking at 2, right? What's the value of f of 2? Look at my graph. Where's f of 2? Bianca? Yeska, thank you, Yeska. Yeah, exactly. Number 3, right? F of 2. At 2, the function says it is equal to 3. So at 2, my function, f of 2, is equal to 3. Part 2, we found the limit, right? The limit as x approaches 2 of f of x. We found that before. We said that was 1. So we're good with part 1. We have the limit existing, the value existing. We have the limit existing. We're good with part 2. The problem is here in part 3. F of 2 does not equal the limit as x approaches 2 of f of x. And this is where we break down, right? We know all the things we have, right? We have all the things. We showed what the value is, we showed what the limit is, and we showed that therefore they're not equal, and therefore it's not continuous because this last part here, it does not meet the criteria. Again, part C we'll have to leave for later. Get this to me by tomorrow, everybody. And what I'm going to do for you, what we're going to do, I have a little review that I want to share with you all. Where'd it go? Where'd it go? Let me just quickly share this with you all. We have a review here. Here. Practice questions for limits. So a couple questions of how do you find limits. Some other questions about limits. We're going to go over this on Monday. There's 25 questions here. Practice those with 5 extra little thinker problems if you really want to stretch your brain. 5 more thinker questions. I'm going to post this on Schoology. This is not a homework assignment. This is a review assignment. So it's not something you're going to get credit for. Well, or I could give you credit if you wanted. Yeah, the extra credit, these 5 extra thinker questions. How about that? Do these 5 questions. That'll be extra credit. How about that? I'm going to post this to Schoology. Try this over the weekend. Also practice the IXL, practice Khan Academy, and make sure, please, you are finishing your Edgenuity assignments. I want the Edgenuity assignments also finished by the end of this week. So, your Edgenuity assignment, your assignment out of the book, these practice questions plus the extra 5 on the bottom if you want to try those. We'll review this on Monday. Your test is going to be on Tuesday. The unit test on Edgenuity, no, do not worry about the unit test on Edgenuity, Maria. Don't worry about that unit test on Edgenuity. I'm actually thinking of turning off that test. I don't like it. I mean, you can, I don't know. All right, yes, goodbye, everybody. Thank you all very much. Make sure you say goodbye in the chat. Once you say goodbye, you are free to go. I will see you all later. Thank you very much.